Mars is the only planet inhabited exclusively by robots. Today, in 2024, the only active agents moving and doing something on Mars are 3 rovers called Curiosity, Perseverance, and Tianwen-1. And that will continue to be the case. Despite the dreams of a space colony on Mars, this colony will not happen, at least in the near future. The dreams of exploring and colonizing Mars are motivated by various factors. Some space exploration enthusiasts argue that humanity needs a space colony to protect itself from possible extinction. If something serious happens on Earth, like a nuclear war or an asteroid, humans living on Mars would continue to survive and keep humanity alive with them. If the dinosaurs had a colony on Mars, they might still be alive today. And this is what I will call the survival argument. Colonizing Mars is a matter of survival. Other space exploration enthusiasts also argue that the commercial and industrial exploration of the rest of the solar system could bring wealth to Earth and drastically improve everyone's lives, ideally having a cascading effect to mitigate the difficulties of material life on Earth, such as violence and disputes between nations. And this argument is what I will call the prosperity argument. Colonizing Mars and space is a matter of quality of life on Earth. During the height of space exploration in the last century, the space race was a form of technological superiority contest between the United States and the Soviet Union. The motivation and results of the space race are a consequence of the national interests of these 2 great powers of the Cold War. But today, in the first half of the 21st century, there is an unprecedented number of independent private companies taking a leading role in space exploration. Northrop Grumman and Sierra Space are examples of companies capable of carrying out their own space missions and are developing expertise in an area that was once the exclusive domain of governments. And before you comment, SpaceX too. The objectives of humans in space are no longer just of interest to countries. For the first time, we have elaborate space exploration missions driven by the ambitions of figures like the Amazon billionaire, Jeff Bezos, and his space exploration company, Blue Origin. One of Blue Origin's explicit goals is to facilitate a future where millions of people travel and even work in space. This is largely motivated by his personal objectives. I personally love space exploration, and I am obsessed with the possibilities of how we, small humans, can separate from our planet and explore the vastness of space. So, first of all, I need to say that seeing humans inhabiting Mars is also a dream of mine. And that is why I am somewhat sad to bring a gigantic bucket of cold water to the ambitions of Jeff Bezos and other dreamers of a short-term Martian future. Humanity in the 21st century is not capable of colonizing Mars in the short or medium term, and attempting to colonize Mars would likely lead to a catastrophe and loss of lives. There are 4 major reasons why no one will be able to colonize Mars or space in the near future.
Hey, Pedro here. This video you are watching was originally in Portuguese, my native language. This is the attempt of our team to translate it to English, and I sincerely hope you enjoy it. Your feedback is extremely important to us. Now, back to the video.
Challenge 1. Leaving Earth. The first major challenge is precisely leaving Earth. Earth has gravity. It pulls objects to the ground. Traveling to Mars means overcoming this gravitational pull and escaping Earth's gravity. In practical terms, we need to move at 11 kilometers per second to escape Earth's gravitational pull. And the best known way to go that fast is by using rockets. Rockets use violent chemical reactions to expel gas in one direction and propel themselves in the other. It is basically using Newton's third law to put things into space. In other words, rockets expel gas backward at high speed to move forward, and they carry with them all the propellant gas they use in the process. This is also why they work in space. Rockets carry everything they need with them all the time. The problem is that this is very inefficient. Let's say that to take 1 ton of material into space, you need to carry 200 kilograms of fuel. So now your rocket weighs 1.2 tons, which is the initial load plus the fuel. So now you need more fuel to carry those 200 kilograms of additional fuel weight, which again increases the total weight of the rocket, and which further increases the need for fuel. In the end, it takes a 40-ton rocket to carry a single ton of useful material into space, with most of the rocket's fuel being used just to carry fuel that is carrying more fuel. Because of this, space travel is very expensive. If the goal is to colonize Mars, the great solution for rocket costs would be to colonize the Moon. A semi-permanent colony with industrial capabilities on the Moon would make the exploration of Mars and the rest of the solar system much cheaper in the long run. After all, the moon is much farther from the Earth's center of gravity than the surface, and it would be much cheaper to launch rockets from there. However, colonizing the moon has basically all the technical problems that colonizing Mars has, so it won't happen in the near future. Challenge 2. Space is dangerous. But the great space enthusiasts are in a hurry, with some wanting to go to Mars in the coming decades. So let's ignore long-term ideas and go straight to Mars. Mars is on average more than 200 million kilometers from Earth, with good launch windows occurring every 2 years and following a non-linear trajectory. A trip to Mars takes approximately 260 days with current technology. And that is basically the average time a typical astronaut spends on the International Space Station. A trip to Mars is on the edge of our knowledge about how space affects human beings. So, what are going to be the problems of this journey to Mars? First, being away from Earth's gravity seems to cause muscle atrophy, and an intense exercise regimen is necessary to minimize the losses. Secondly, the lack of gravity seems to affect vision. Astronauts tend to develop vision problems after months in space. How serious these vision problems can become is still unclear, because we have never left any astronaut far from Earth for a long time. Third, preliminary research indicates that living in space for a long time can cause neural degeneration, affecting fine motor control. And besides, on Earth we are protected from the worst of the sun's radiation by our planet's magnetic field. The same is not true in space. Because of this, prolonged exposure to radiation can increase the chances of chronic diseases during future missions to Mars. And none of these problems mean immediate death or certain mission failure, but these factors can weaken the members of a mission to Mars. The combination of the physiological problems generated by the journey with the unprecedented challenges of a Mars mission can lead to a catastrophe. And the planet Mars itself is not exactly a safe place. Yes, the presence of gravity can mitigate some of the effects of muscle and neural deterioration. But the risk here is significant, because we do not know. There is no research on the effect of reduced gravity on humans. Furthermore, Mars does not have a magnetic field, so we will need to find ways to protect the astronauts from the solar radiation present on the surface of Mars. And here is a good moment to remember that around 1% of the soil on Mars is perchlorate, which is a salt based on chlorine and oxygen that is toxic to humans. This means that prolonged direct exposure to the surface of Mars will cause health problems. A base on Mars needs to have an efficient way to avoid contamination by perchlorate. After all, this substance is also a problem for potential plants used to produce food and oxygen. Challenge 3. Keeping humans alive. We will need food and oxygen to keep humans alive for long periods. Mars has water and has oxygen in the water. A base with adequate infrastructure could use Mars water both to produce oxygen and for drinking. Furthermore, a Martian base would make an enormous effort to recycle everything possible. From the air breathed to biological waste, everything would be reused in one way or another. The recycling process would be facilitated if the base on Mars had inhabitants who could use the chemicals that humans reject. For example, humans exhale carbon dioxide, CO2. However, plants are capable of breathing CO2 and producing oxygen and food in the process. Living on Mars for long periods means using our biological waste to feed some type of living being that produces food with it, whether it be plants, fungi, or some type of technology that can print food. This is the logic of a closed ecosystem, which is capable of persisting even when isolated from most external variables, except for an external energy source, which would basically be the sun. It will be necessary to create an efficient and sufficient resource cycle for humans on Mars to survive on their own. Humans have already tried to create closed ecosystems here on Earth. The largest of these was the Biosphere 2 experiment. This experiment confined 8 humans in an ecosystem that only received sunlight from the outside world. And the project had controversial results. The Biosphere was driven primarily by the curiosity of the project's investors. Therefore, it did not follow strict scientific methodology, and for the same price, multiple smaller experiments would probably have generated more useful data. Furthermore, the ecosystem was unable to replenish the oxygen it was losing at an adequate rate, and as the experiment progressed, there was less and less oxygen to breathe. Another problem was the factor of human psychology. The 8 volunteers in the experiment split into 2 groups of 4 people, and each group hated the other group. It got to the point where each group pretended that the other 4 people in the rival group simply didn't exist, and they didn't even look each other in the eyes. If something like this happens to astronauts inhabiting Mars, it would be the end of the mission and probably the lives of the astronauts. Challenge 4. Spatial psychology. And here comes a problem that I have ignored until now. Surviving is not enough. The inhabitants of Mars need to be able to remain stable enough to make decisions for the collective good. To date, apart from a space strike, there has been no episode of crisis in space caused by the psychological deterioration of an astronaut. But astronauts are selected to be resilient individuals capable of operating in situations of extreme pressure. An independent colony on Mars would not have the luxury of being so selective with its members. To maintain a colony independent from Earth, a large number of people would be needed, the more the better. But going to Mars would basically be a sentence of exile from Earth. You would probably never again inhabit a world capable of sustaining your existence naturally. This means giving up even the comfort of being able to open your front door and breathe the air outside. The psychological profile of the first Mars colonizers would likely be closer to that of Arctic and Antarctic explorers than astronauts. And these types of people are not always the most stable or the best at estimating risks in a cold and calculated manner. A successful colonization of Mars needs to create a breathable atmosphere, a cycle for water and food, as well as combat stress and potential psychological issues, and maintain mission cohesion. This means having both survival infrastructure and entertainment infrastructure, as well as ways to relax. And all of this costs energy. Our best bet would be nuclear fusion energy, which is not yet technically possible. So we will need conventional nuclear reactors based on nuclear fission, which are extremely efficient, but they can cause catastrophic failures if something goes wrong. And this type of failure can be worsened by the negative consequences of inhabiting a world with reduced gravity and extremely high stress. Not to mention that to operate a nuclear fission reactor on Mars, we need to send nuclear material in rockets, which is possible, but humanity likes to avoid it because rockets explode. And during a launch, one of these exploding could cause radioactive contamination of large portions of the planet's surface. And to make matters worse, this whole scenario is extremely hypothetical. We do not know how plants will behave on Mars, what kind of treatment will be necessary to make Martian soil viable for plants. We do not even know how Mars's reduced gravity will affect food growth. We also do not know how to efficiently build infrastructure on Mars. We are not sure how much of Mars's natural resources can be efficiently used in a first colony, or how much of the resources we will have to send from Earth. Only now are we beginning to investigate the psychological effects of a mission to Mars through simulations with volunteers. And this is a simulation of a mission with a return date to Earth, not a permanent colony or a long-term mission. All we know is that creating some kind of permanent colony on Mars will take a lot of resources. And as long as the Mars colony cannot create an ecosystem capable of sustaining humans, it will depend on more resources sent from Earth. The rocket launch window to Mars occurs every 2 years, with trips taking almost a year. If any crisis happens on Mars far from a launch window, help from Earth would take a long time to arrive. A partial occupation of Mars would be extremely dependent on Earth and extremely fragile to accidents. And here we return to the first problem. Sending all these resources into space is very expensive. It seems impossible to successfully colonize Mars without sending an unprecedented amount of resources into space. So, why should we colonize Mars? Okay, I know things have gotten intense and it seems like colonizing Mars is impossible. So this is a good point to review the initial motivations for exploring and inhabiting Mars. First, let's review the argument of wealth. Having access to the mineral resources of Mars would basically double the amount of accessible metals. It would be possible, in theory, to industrialize Mars and transfer part of human industrial production to the Red Planet, which would reduce the negative impacts of industry on the biosphere of our planet. And since Mars does not have any living beings, as far as we know, the industry would not cause any harm to the Red Planet. And in theory, this could bring wealth and prosperity to the planet, in one way or another. But the argument of wealth has a big problem. We do not have any efficient system to transport matter from Mars to Earth or from Earth to Mars, especially on the scales at which humanity consumes resources. For example, humanity extracts billions of tons of iron every year from the surface of our planet. Iron is one of the most abundant resources on Mars, and even if it were easy to extract iron from Mars, moving billions of tons from Mars to Earth is an unsolvable problem. Given our current technology, it is impossible to bring large quantities of resources from space to Earth. And this problem is equivalent to trying to land an asteroid on our planet safely and cheaply, which, if you ask me, is not a good idea. Especially because it is still much cheaper to extract this iron from Earth itself. But one day the easily accessible iron here on Earth will run out. However, it is still much easier to extract iron from Earth than to colonize Mars. The survival argument has an even worse problem. For humanity to survive on Mars if Earth were to end, the colony on Mars would need to be self-sufficient in food, energy, water, and population. And this is a major problem. To put it very directly, it would require babies and pregnancies on Mars. Human societies depend on new humans to continue functioning, especially if the goal of the colony is the survival of humanity. Now imagine everything I mentioned about the physiological and psychological difficulties of inhabiting Mars and apply it to pregnant women, babies, and children. This is a frightening scenario. It is one thing to have voluntary humans face the difficulties of Mars. It is another to force newborn babies who have no choice to inhabit a place as hostile as Mars. This is not to mention the fact that we have no idea how reduced gravity, higher background radiation, and lack of sunlight affect babies. And it is not even possible to find out without completely unethical experiments. The only scenario in which having babies on Mars seems minimally reasonable is an extremely advanced Martian colony, capable of ensuring the safety of children and dealing with any unknown complications that may arise on its own. And nothing like that will happen in the short term. The exact challenges of colonizing Mars are still a big unknown. Even designing research to clarify the challenges of colonizing Mars is difficult. An attempt to colonize Mars in a rushed manner would be a disaster. And unless all ethical guidelines were ignored, a Martian colony would spend the next decades or centuries being extremely dependent on Earth, largely due to the need for resources, but especially due to the need for humans to work in the colony. If we want to colonize Mars to ensure human survival, we first need to ensure that humanity will survive on Earth for the distant future, which is already quite a challenge. But then I need to raise a point. No one needed to go to the South Pole or the North Pole. These places are extremely cold and inhospitable to human life. But we have photos from there and even from nearby bases. And thousands of people have already climbed Everest, which is another terrible place for human existence. Humans go to places where they shouldn't be. This is part of our nature for one reason or another. Mars is a much worse place for humans than the most extreme locations on our planet. For most of us, this sounds like a limitation. But for others, it sounds like a challenge. If humanity survives, it will try to explore and colonize Mars. It is a question of when and how, not if. So, is there any suitable way to overcome the challenges that a space journey to Mars imposes? Yes, there is. The exploration and colonization of Mars depends on a psychological resource called patience. And yes, I know that this is lacking nowadays. Any hasty action will result in tragedy. We need to create the technological infrastructure to explore space regularly, and perhaps significantly advance our space travel technology in the process. We need to advance immensely in our understanding of space medicine and psychology, especially in the gravity of Mars. We need to visit Mars on research missions and study in detail potential colony sites. And maybe we even need to build that rocket factory on the Moon before we even try to create a colony on Mars. We also need to ensure not only the survival but also the excellence of humanity on Earth for the next centuries if we truly want to colonize Mars one day. Without a future worthy of an advanced civilization, where scientific advancements are treated as important and the safety of Earth's inhabitants is respected, we will not be able to survive on Mars. If we do not learn to maintain a technologically advanced civilization on a planet shaped by life, there is no chance at all that we will be able to do the same in a poisonous desert like Mars. Reaching and surviving on Mars is not just a technological challenge, but a moral one. We need to learn to solve our problems here on Earth if we want to have a real chance on Mars. Mars is a prize for a humanity that has overcome its technological adolescence and not a backup planet to save us from our mistakes here on Earth. So I ask you, if you were invited to go on a one-way trip to Mars to be one of the first colonizers, what would your answer be? Would you go? Type your response in the comments. Thank you very much and see you next time.